and this is the normal vector of the interface. And we consider an incident wave having k given by KINC. Then we know that we may have refraction wave and we may have refraction wave Then this result tells us that KINC, K reflection, and N are all in the same plane. OK， 它们全部都在同样一个平面上。那我们把这平面当成是 A 版的话啊 ，if the same plane is just the black hole, then I can choose the tangential component of the K incidence to be x. Say, suppose this direction is the x direction. So this, now we do not need to consider the y direction. So this result tells us that K1x is equal to K2x However, here we have epsilon1, mu1 parameter. Here we have epsilon2, mu2 parameters. And epsilon1, mu1 give us refracting index n1, and epsilon2, mu2 give us refracting index n2. And this means that the magnitude of K1 times the angle of incidence is θ1, and angle of refraction is θ2. And here we have θ1 prime. Then this means that the magnitude of K1 times sine θ1 is equal to我把这个叫 K1 好了，这叫 K1 prime， 然后这个叫 K2， 就把这叫 K2 好。I denote this as K1, this as K prime 1, and this as K2. The magnitude of K1 times sine θ1 gives us the x component of K1. This must be equal to K prime 1 times sine θ1 prime, and K2 times sine θ2. Okay, so what is the magnitude of K1? This is just omega over c times n1. N1 is the refracting index, the first medium, and in fact this is also equal to K prime 1. K1 and K prime 1 have the same magnitude but different direction. And what is K2? The magnitude of K2 is omega over c times n2. So if we substitute these quantities into this equation, we get omega over c n1 sine theta 1 is equal to omega over c n1 sine theta 1 prime is equal to omega over c times n2 sine theta 2. Okay? So finally we find n1 sine theta 1 equal to n1 sine theta 1 prime equal to n2 sine theta 2. So according to this, we find theta 1 prime is equal to theta 1, and n1 sine theta 1 is equal to n2 sine theta 2. This is the Snell's law. So what is Snell's law? Snell's law is in fact just the phase connection condition. OK， 就是相位不变的条件，这样子而已。好，就说 when a wave propagated from medium 1 to medium 2, on the two sides of the interface, the phases are the same. Okay, the sameness condition of the phase give us the equality between the tangential component of the K vector. Okay, so the tangential component of the K vector in medium 1 is equal to the tangential component of K vector in medium 2. And we can translate this language into the expression of so-called Snell's law. So Snell's law just gives us the boundary can be just derived from the phase connection condition. Since this derivation has nothing to do with the so-called transverse character of the electromagnetic wave, so for acoustic wave, we can also have Snell's law. 就声波也有施耐定律，啊，声波也有施耐定律。So how to understand the Snell's law of acoustic waves? Remember that what is n? N is just the relation. C is the speed of light. Speed of light divided by a factor called refracting index gives us the speed of wave in the medium. Okay. However, in acoustic wave, we do not have vacuum, but you can choose some kind of medium as the reference medium. You can define this kind of medium as so-called vacuum. Then you know that the speed of acoustic wave is inversely proportional to a factor. We can define this factor as so-called refracting index. So you can apply the Snell's law to acoustic wave. 就是说，你对声波，你也可以去使用所谓的施耐定律。其实说穿了就是，比如说这样写啊。意思就是 sin theta 2 is equal to n1 over n2 times sin theta 1， 但是 n 的比值是 v 的反比。This is equal to v2 over v1 sin theta 1. Okay, and this v can be calculated by For elastic wave, we have two kinds of V. One is for the longitudinal wave, the other is for the longitudinal transverse wave. Okay. So if you consider the longitudinal wave, the V